um velocity time graph. Now, velocity time graph is actually talking about acceleration. It's actually talking about acceleration. Remember, acceleration is velocity over time. So velocity time graph is actually talking about acceleration. Now recall I told you guys that we have what we call deceleration and what we call acceleration. When you say a body is undergoing acceleration, it means the speed is increasing. When the body, or let's say the velocity is increasing, yes. But when you talk of deceleration, it means that the body is slowing down. For example, you start up a vehicle and you start increasing the velocity, or you start increasing the velocity, you find out that the vehicle is moving very fast. That is known as acceleration. Now, but when the vehicle is moving very fast, that is not acceleration, is accelerating, is moving very, very fast. But when you apply brake, the vehicle starts slowing down. That is no longer known as acceleration, is rather known as what? Deceleration. Deceleration is also called retardation, or negative acceleration. Now, in this video, you'll find out that why they call it negative acceleration. You will see it by yourself with calculations. So now, these are basically jamb questions. Now, in one particular year, they draw a diagram like this, and they draw a line like this. Now they said in the diagram, they were asking what does this mean. They place velocity here, they place time here. This means acceleration. Now take note that ascending line signifies acceleration, shows that the body is moving very fast, shows acceleration. Please take note, ascending line shows acceleration, that the body is accelerating, is moving very fast. While descending line shows retardation or deceleration, shows that the body is slowing down. Now, they are in this graph, they are not the same, because if you look at it very well, you find out that, let's say, okay, let's say this V1 is the initial velocity. The V1 is the initial velocity, while the V2 is the final velocity. I can also put U here, they are the same thing. Then, same thing here, V1 is the initial velocity, V2 is the final velocity. Now, let's say the vehicle starts with, let's say the vehicle starts with a velocity of 2 meters per second. Remember, before then, in the velocity time graph, the vertical axis shows the vertical axis represents the velocity, while the horizontal axis represents the time. Vertical axis can also be called the y-axis. Horizontal axis can also be called the x-axis. Same thing applies here. The velocity is always at the vertical axis, while the time is always at the horizontal axis. Now, let's say a car starts moving with a velocity of 2. Then you start up increasing the speed. Let's say, you start up increasing the velocity to, let's say, 8 meters per second. And let's say let's say T1 is, let's say 2, then T2 is 4. Now, how can we calculate the acceleration? Remember, acceleration is equals to change in velocity over time, which is V2 minus V1. Since there are two times, we can put T2 minus T1. So to be equals to, our V2 will be what? 8. Then our V1 is 2. T2 is 4. T1 is 2. This one will give us 6. Then this one will give us 2. Our answer will be 3 meters per second squared. Now, this shows that the body is accelerating. The acceleration of this body of the car is 3 meters per second square. It shows that the body is accelerating very fast. Now, let me apply the same parameters. Let me apply the same figure to this one to tell you that the body will slow down, to show you why they call this deceleration negative acceleration, because our answer we end up having a negative sign. Now, okay, now remember, I told you guys that these two graphs are two different things. Because if you look at this first graph, find out that the V2 is already here, is usually higher than the V1 in this first graph. When if you look at the second one, the V1 is higher than what? The V2. That's why if you look at it, the V1 is usually like higher than V2. That is in deceleration. But in acceleration, the V2 is higher than V1. Okay, now let us place the same values for both of them. Our V2 will be, our V1 will be 8, then our V2 will be 2, then our T1 will still be 2, then our T2 will be 4. Now, we all know that acceleration is change in velocity over time, which is V2 minus V1 over T2 minus T1. Now, our V2 is what? 8, that is 2. Then our V1 is 8. Our T2 is 4. Then our T1 is 2. Subtracting this one will give us 2 minus 8 to give us minus 6. 4 minus 2 give us 2. Minus 6 to go into 2, divide 2 give us what? Minus 3 meter per second square. It shows that this one is talking about deceleration. This is why they call it negative acceleration. From the graph, you know. Remember, the V1 in deceleration, the initial velocity is always greater than the final velocity. Now, let's just use our normal basic knowledge. Now imagine you start a car is moving with a velocity of 8 meters per second. Then you apply a brake to slow it down. The brake causes the velocity to decrease to 2. Remember, our car was moving with the velocity of 8. Will I put V2 here that is equals to 8? No, because this V1 is initial velocity, because it was moving with the velocity of 8. Then we apply a brake, the velocity reduces. Our V2 will now be 2. So, what if you solve everything? You find out that the body like decelerates, like the body slows down. So, in summary, things you should note here is that as this line, if they ask you, it shows acceleration, that the body is accelerating. Then why this one shows that the body is decelerating. Shows that the body is decelerating. This one shows that the body is accelerating. This one shows that the body is decelerating. So this is all about velocity time graph. Then before I forget, there's still one other one we should know of. Now there's what we call now remember, when the line is ascending line shows acceleration, descending line shows deceleration. Then horizontal line shows uniform motion. It means uniform motion means no acceleration. Uniform motion. This horizontal line is also a jamb question. Horizontal line, if they give like this, we ask where is the acceleration of the body? Acceleration will be 0. Horizontal line shows no acceleration. In other words, the body is not moving at all. You know why? Because there's no change in velocity. Like there's no change in velocity. Since there is no change in velocity, A equals to change in velocity over time. Okay, which is there's no change in velocity. V will be 0. Then let's say T2 minus T1, everything will still give us 0. So there's no change in velocity. Horizontal line shows uniform motion. That is no acceleration, no motion at all. A is 0. So these are the 3 graphs you need to take note of. When they give you, in summary, when they give you a graph that shows ascending line, you know that they are talking about acceleration. When the line is descending, know that they are talking about deceleration. Acceleration means the body is moving very fast. That is acceleration or accelerating. When deceleration or negative acceleration or retardation means the body is slowing down. For example, on a vehicle, you wanted to hit a cow or a goat. You apply your brake fast to stop the car. That is known as deceleration. So deceleration means the body slow down. Acceleration means the speed of the body increases as the body is moving very fast. Then the last one, horizontal line shows no acceleration. Horizontal line shows no acceleration. That is, the body is not moving at all. A car at rest that is not moving. Imagine if the velocity, like a car at rest, is not moving at all. It's zero. Remember when I said at rest, okay, zero. It's not moving. Since it's not moving, there is no change in velocity. Since there is no change in velocity, there is velocity is zero. No matter what is our time, since velocity is zero, because there's no, like, the body is not moving at all. Remember, when they're talking about change in velocity, it means the body is moving. Then when there's no change in velocity at all, that is v is zero. Imagine, no matter the value we have in here, let's the value we even have in here is 100. 0 going to 100 still give us 0. So therefore acceleration is 0. So horizontal ascending line shows acceleration, that is, then descending line shows deceleration. Horizontal line shows no acceleration, or we can say uniform motion. Uniform motion means like constant motion, that is, or constant acceleration. This, take note, if you don't see no acceleration, also known as the same thing as constant acceleration. Constant acceleration, that is not moving, a is 0. So yeah, this is all about velocity time graph. In our video, we do calculation on velocity time graph and on equation of motion.